Now we're looking at the environmental considerations. These are statutory. You've got specific requirements for applications such as wind speed limits, relative humidities to consider, and we're going to discuss delta T. As an applicator, when you're in the field, you make your recordings and you jump in the cab. To back you up a little bit, let's put a wind ribbon on that spray unit. So you can pull up anywhere and make a determination of what the downwind no sprayer impact may be. So that ribbon, if it's blowing towards a censored area, you know you've got to make some decisions. If you've got buffer zones that are a requirement of your application, why not peg where that buffer zone would come into play? So if an applicator goes in and you are concerned about the buffer zone impact, start from that peg so that you've got a safe zone and you've allowed for that. Come back at a later period and spray that buffer zone area when the wind is blowing from the right direction, keeping in mind of a downwind no sprayer buffer zone. Let's consider the 24-hour risk profile. Your high risk areas for spraying are going to be going into the evening and coming out in the early part of the morning, keeping in mind that the inversion layer will not burn off until the earth heats up again, so it effectively burns off from underneath. Some of the traps that applicators fall into thinking, well, I've got a breeze, I've got 3 to 5k breeze, I'm good, that's what the label says. But to be spraying safely under inversion conditions, you need 11k breeze. So effectively think of the inversion layer as a Tupperware container lid. It's keeping out the synoptic wind, right? Now you can hop out of the tractor and you can feel a breeze, but that breeze is possibly a topography effect. So you get drainage winds that are coming off as the drainage going down into lower areas in the catchment, generally where sensitive crops are growing with irrigated water. So we have this problem that we get this concentration potentially of pesticide that if we have got droplets that aren't getting to ground under their own weight and they're getting smaller, they can go significant distances over that period. If you had an 8-hour period of a 3k breeze, that's 24k's, something could get pushed if it's not going to land or suspend. If that material then drops back out, is reformulated, bang. Every rain droplet ever formed is formed on a dust or a salt particle. So we have a situation if we're getting gain into the atmosphere from material leaving the application site, whether it be from evaporation, it can then get complex back into that situation under inversions where we turn the atmosphere upside down and we start bringing that material back. Or potentially it rains out in a situation. Every rain droplet's got a dust particle within it. Now, delta T is an interesting or contentious topic, we could say. There's a feeling now that we shouldn't pay that much attention to delta T, but I think we need to. Delta T is a measurement of evaporation potential. If we've limited the amount of night spraying, it's now important that we manage having to spray in more heat. And it's very hard to spray in more heat and ignore temperature. The other way you can measure delta T is to look at temperature and relative humidity and go to a delta T table. The traditional method was using a wet dry bulb thermometer. The wet thermometer is being cooled if the air is hot and dry. The dry thermometer is just measuring temperature. So if you had a 20-degree wet bulb and a 30-degree air temperature, you've got a change in temperature there of 10. So the air is hot and dry. So the spray planning process becomes really critical here, which we'll talk about later. But if you're spraying into more heat, you have to manage that with spray quality. You need these chemistries to stay wet on the target long enough to get in so that you can have the biological effect you're chasing.
So Craig's talked about the importance of never spraying during a surface temperature inversion and also the importance of recognising the right delta T. And that's why Bayer have developed the XtendFlex cotton spray app. This is a web-based tool that's mobile friendly. Growers will be able to go onto our website and find the link to the tool. And this will help growers look at the risk of an inversion occurring for every hour of the day out to a 5-day period for their specific location. It'll also include other weather variables such as wind, temperature, rainfall probability, and it will also have a delta T model there as well. We've developed this app using weather towers installed across key cotton regions in Australia, And each of these weather towers is 10 metres tall, and they measure temperature, humidity, solar intensity and wind speed at multiple heights along this 10 metres. And that's allowed us to train the model to predict the risk of an inversion against gridded weather data sets such as the GFS and the TWC models.